Here's a DC circuit that has 3 resistors and 1 capacitor, and we're looking for the steady state condition for the volts. And then we'll look at this right here. And again, we're trying to measure volts across the capacitor here. It's a 100 microfarad capacitor, and we have a meter that's connected in parallel across it. So we're assuming that volts is what we're going to need to measure there. Now, a steady state condition, this capacitor is going to be totally charged, and the current on this branch is going to equal 0. Because when the capacitor is totally full, no charges will pass through. So really, electricity is going in this line here, okay, which is a simple series circuit then. So then I'll say R total is equal to 5.1 ohms plus 4.3 ohms plus 11 ohms. And that's equal to 20.4 ohms. So that's the total resistance of the entire circuit. So if I can get the volts across this branch, that also must equal the volts across this branch here, since they're parallel to each other. So if I know the volts across these resistors, I will also know the volts across the capacitor. So let's go ahead and do that. One more time, let's use V equals IR for Ohm's law. And I know the voltage of the circuit is 12. And I'll say times equals I, and really that's I total, and times 20.4. Okay, and the current is equal to 0.588 amps. Okay, so I want to find the volts across this resistor here. So I'm going to say V equals IR again, so V equals 0.588. I'm going to multiply that by the resistor's value of 5.1. And then I'm going to get a value of 3.0 volts. That will be on this resistor here. Now I can just apply Kirchhoff's rules from here. I know I've got 12 volts here. If this resistor takes 3, I must have 9 left. Okay, and there'll be 9 here, and then of course 0 on this end. So I know that these resistors are going to use up the other 9, because the sum of all volts across any closed loop, again, has to equal 0. So if I know there's 9 volts across this branch, there must also be 9 volts on this branch. So I'm going to record 9 volts for the capacitor's voltage value there. And that's how you do it. You could also get current on this branch and calculate the volts on this and the volts on this, and then add those two together as well. But I prefer just to use Kirchhoff's rules from the beginning.